Hello, and welcome to another episode of Mad Scientist Brewing Beer Education Series. Last week's video talked about the different kinds of permanent draft systems that are available, but it's also important to know about all of the components involved in those systems. There are two sides of a draft system, the gas side and the beer side. The gas side begins with gas cylinders, which contain the gas used to move beer through the system, which is either beverage-grade CO2 or a blend of CO2 and nitrogen called beer gas. Gas cylinders come in different sizes depending on the user's needs, and can also be delivered in large bulk tanks outdoors, which are filled from a gas truck. Gas pressure in either kind of vessel is anywhere from 600 to 1200 psi. If utilizing a nitrogenized beer or a long draw system, nitrogen gas is used either as a premixed gas blend or using a gas blender to combine CO2 and nitrogen at the desired ratio. The next component in line is a gas regulator, which controls the flow of gas from the source to the kegs. These have pressure gauges that allow the setting of pressure and monitoring gas levels in the tank. All systems will have a primary regulator, which controls the flow of gas from the gas source, and some will also have secondary regulators, which can be used to control the pressure applied to individual kegs if desired. The gas moves from the source through the regulators and to the keg through gas lines, which are thicker than beer lines to withstand higher pressure and are often colored to help differentiate them from the beer lines. The gas line ultimately connects to the coupler. The coupler is what attaches to an individual keg to allow gas to flow in and beer to flow out. The gas side of the coupler allows gas to fill the headspace of the keg and push beer out using pressure. That covers the components of the gas side of the draft system. For the beer side, we're starting with the same coupler that connects the keg. When engaged, a ball in the neck of the keg is pushed down, and gas is allowed to flow into the keg, while beer is forced out of the other end of the coupler into the beer line. The keg itself has several different sizes and styles depending on the region where it's used. And likewise, so do the different couplers. In the US, the Sankey D-style coupler is most common, while most kegs are the half-barrel 15.5-gallon or the sixtel kegs, which are 1/6 of a keg and hold about 1/6 of a barrel and hold about 5 gallons. For direct draw and shorter air-cooled systems, beer line connects the coupler directly to the faucet. It can be simple vinyl tubing, but for longer systems, a special tubing called barrier tubing is used, which is less permeable to oxygen. For long draw systems, there are additional components before the faucet. The section of beer line coming out of the coupler, called a jumper line, connects with a wall bracket. Commonly before the wall bracket, there is a device called a foam-on beer detector, or FOB. The FOB seals off the beer line when a keg empties and keeps the line pressurized while the keg can be changed. From the wall bracket, the beer enters a trunk line, which is a bundle of several beer lines together with glycol cooling lines wrapped together in insulation. The trunk lines run most of the way from the beer storage cooler to the faucet. If the distance is very long, a beer pump can be utilized using mechanical force to move beer without the risk of overpressurizing it with gas. At the other end of the trunk line, another short section of vinyl beer line is used to connect each line in the trunk line to its respective tap. This is here to maintain draft system balance, which I'll cover in the next video. Ultimately, the beer line meets up with a shank, which connects the beer line to the actual faucet. In many direct draw and long draw systems, draft towers are used and contain the shanks and faucets, and their interior must be kept cool by either forced cold air or glycol lines. Other systems will have the faucets and shanks connect through a wall or decorative tap board without any vertical rise. The faucet is the last component from which the beer is actually poured when the tap handle is pulled. There are standard faucets, which seal in the rear of the faucet and are vented and need to be carefully cleaned, as well as forward-sealing faucets, which are easier to clean. Some faucets have flow control levers, which can meter the flow of beer if it is pouring out too fast or foamy. There's also the nitro tap for serving nitrogenated beers, which has a special restrictor inside that helps break nitrogen out of the beer and give it a characteristic cascading effect. So, in summary, that's a brief overview of all of the components in the draft system. There's a lot more to cover in the topic, and actually maintaining and balancing a draft system, some of which I'll cover in the next video. If you want to learn more in depth about any of these draft topics, the Draft Beer Quality Manual put out by the Brewers Association is kind of the Bible for studying anything related to draft service. So especially if you are working behind the bar in the industry, it is something that you will want to read. That's it then for this video, and until next time, cheers.